Okay, students, we're going to go over your multiple choice practice test here, specifically for those who might have been absent. Okay, in the figure, I can't even read that. PS is congruent to RQ. Which theorem can you use to prove the triangle SQR is congruent to QSP? Well, I know I can get this one, QS congruent to SQ, by reflexive property. Remember, that's one of our free ones, reflexive property. And then I have right angles here. And so I have HL theorem, hypotenuse and a leg, hypotenuse leg. Number 2, a trapezoid and a rhombus are both what type of shape? So I look at a trapezoid and a rhombus. What do they only fall underneath? A quadrilateral. Okay, you get your trapezoid up here and your rhombus down here. The only thing that they connect up to is the quadrilateral at the top of the hierarchy. Okay, goes up to kite here and then quadrilateral, but trapezoid just goes right up to quadrilateral. All right, next. The woodworker draws cut lines on the top of a wooden disc. She uses the drawing of her design as shown. The circle O chords BF and CE are perpendicular to the diameter. Okay. AD, which of the following relationships is true? CH is congruent to HE. So when it's perpendicular to the diameter, that diameter bisects the chord every time. So CH is congruent to HE. Number 4, which of the following statements do not show that the right triangles shown are congruent? Okay, so if I have angle K is congruent to angle K, that does me good. Angle S is congruent to angle, or L is congruent to angle S. Okay, I have an A in one, and just an AA in the other. Okay, so we want do not show that they're congruent. That doesn't show anything about congruence. The other ones do show congruence. I'll just do one of them, for example, the first one. KM is congruent to RT. KL is congruent to RS. Well, there we have the HL theorem, hypotenuse leg. Okay, and so these other ones will work too. C is the only one that doesn't work. Which of the following is not always a parallelogram? Remember, we got a parallelogram right here that goes down to rectangle, rhombus, and then they go down to square at the bottom. Okay, so a parallelogram, rhombus, rectangle, and square, rhombus, rectangle, and square are parallelograms. Kite, remember, kite is up here. Kite is not a parallelogram. Okay, 6. We want to find out which one is true. BA is congruent to BE. Okay, we know that because those are both tangents. If I draw this bigger here, if I take a point outside the circle and draw a tangent, 2 tangents to it, the circle from the same exterior point, then those distances are congruent right there. And so that's just a blown up piece of that right there. 7. Choose the correct conclusion. The triangles are congruent by HA, hypotenuse angle. There's hypotenuse. Remember, in order to be a hypotenuse, it has to be a right triangle. There's our right angle symbols, so we know it's a right triangle, hypotenuse, and there's the angle. Okay, so this book uses hypotenuse angle. You could have also called that AAS. We had our other ones. Okay, that's also AAS right there. But this book also has a name for it with a right triangle. It's called hypotenuse angle. Which of the following is a property of all squares? The diagonals bisect each other. Okay. On a square, the diagonals do bisect each other. Okay, where does that come from? That comes from a parallelogram, right? Parallelogram, the diagonals bisect each other. And of course, the square is a parallelogram. Okay, opposite angles are not congruent. Yes, they are. They're all 90 degrees. Opposite sides are not congruent. Yes, they are. They're all congruent. No sides are parallel. Yes, they are. The opposite sides are parallel. Okay, number 9. For which of the following conditions would arc AB be congruent to arc BC? Okay, and we have if AB is congruent to BC, okay, um, so that chord length is the same as that chord length. The equal chord lengths mean they have the same central angle right there and the same arc measure. Okay, equal chord lengths have equal chord measures. You need to remember that. All right, choose the correct one. So here we have a vertical angle there, and I can get my free point from. It gave me that and that. Okay, choose the correct conclusion. The triangles are congruent by HL. Yes, there's an H and L right there. The triangles are congruent by leg angle. Leg there and an angle there. Yes, the triangles are congruent by hypotenuse angle. Hypotenuse there, angle there. And so all of the above are true. Okay, again, leg angle, this right here would be SAS, for example. You call it SAS there, or if we use this one right here at the right angle, you call it ASA as well. Okay, so just know that. Which of the following has congruent base angles? All isosceles trapezoid. When I see isosceles, the first thing I think is base angles are congruent. Okay, isosceles was isosceles triangle, isosceles trapezoid, base angles are congruent. Okay. Which theorem used to prove GNO is congruent to EON? Well, this side is in common to both of them. Okay. So then I have a right triangle and I have leg, which also is SAS here. And there's that one right there. There's your leg here, the right angle, also SAS. Okay. What's the following property is a property of all rectangles? Opposite sides are congruent. It's true for all rectangles. Okay. This one has an error in it. Okay. Um, these two are congruent. That means these lengths are congruent. Okay. Length of OB is 10. What's the length of YZ? Okay. YZ, they had down the answer is 10. If YZ is 10, then it should have been saying AB. Instead of OB, that should have been AB is 10. AB is 10 right here. Then YZ is also 10. Okay. Since these are equidistant from the center, then the chords are the exact same length. Okay, they're perpendicular. That means it goes to the diameter. Okay. Next, on 13, all you're doing is filling in what allows you to say this. Well, those are radii. Those segments are here, so the answer is radii of the same circle are congruent. All radii are congruent of the same circle. Okay, so with their whole proof, but all you gotta do is fill in that one. All right, 19. Can you show that those two are congruent? Select all that apply. Oh, which can you use to show? So we have to show that these are congruent. So AC is congruent to DF. Angle C is congruent to angle F. Okay, um, technically that would be enough right there because you have already that's perpendicular to that. So you'd have AAS. Okay, um, CB is congruent to FE. Okay, and so if you didn't use the right angle, you'd have SAS that way right there. Okay. Um, Angle A is not congruent to angle F. Okay. A matches up with D over here. So those are not corresponding. Okay. A matches up with D. I mean, sorry, A matches up with F, not D. Okay, so I could use any of those right there. What's the following do you need to show that triangle ABC and XYZ with the right angles at C and Z are congruent by the HL? So you want to draw this out. It says angle C, so A and B. Draw another one. And it says they have the right angle is Z, X, and Y. And we need to be by HL. So we have to say that that's congruent to that, and then what are the sides? So I have to say AB is congruent to XY. There's my hypotenuse. Now I have to name one of the pairing of corresponding sides. I'm going to look here for corresponding sides right there. Okay, so AC, first and third, matches up with XZ. AC matched up with XZ. Okay, and there's my HL. These right here are angles. I'm not using angles at all. For HL, I need a hypotenuse and a leg. So I can immediately cross those two out, which means it's got to be the other two right there. 17, which of the following always has four congruent sides? A square does, and a rhombus does. Which of the following always has opposite sides that are congruent and parallel? Okay. That'd be a parallelogram, but that's not listed here. Everything under the parallelogram, which is rectangle, rhombus, and square. Okay, that wraps up all your answers and understanding of Mod 2, Topic 3 practice test.